Two taxi services operate in Ballarat. Terry's taxis have an initial fee of $8.50 and a rate of $2.50 per minute after that. The other taxi service is operated by Glenda. Glenda's taxi service charges an initial fee of $13 and has a rate of $1.90 per minute after that. For part A, we want to write an equation to model the cost of a taxi ride with Terry. So we can say that the cost of the ride is C, and I'm going to give this variable a last name by using a subscript. So that little t there is a subscript, and it stands for the cost of Terry's taxi. And it is going to be equal to the $8.50 call out, so $8.50 plus the $2.50, and we're going to times that by the variable t to take into account that per minute it costs $2.50. For part B, we want an equation to model the cost of a taxi ride with Glenda. So again, it's still cost, but this time we're going to call it C subscript G. So that stands for cost of a taxi ride with Glenda. And that is equal to 13, which is the call out fee, plus $1.90 for every minute that you travel. For part C, we're asked what values of t can the equations found in part A and B take. So because t stands for time, or it represents time, we need t to be greater than or equal to 0. That's the set notation. We can also write that in interval notation. So we could also express this as t is an element of 0 included to infinity with a round bracket meaning it's not included. Andy needs to get from Alfredton to the Blue Pebble, and he knows it will take him exactly 10.5 minutes. What is the cost if Andy travels with Terry? So here we have the cost with Terry is equal to, and we've got the equation up here, which we found on the previous slide. So it's going to be $8.50 for the call out plus 2.5 times the amount of time, which is 10.5 minutes. So $8.50 plus 2.5 times 10.5. If you put that in the calculator, you find that is equal to $34.75. For part E, we want to find out what the cost is if Andy travels with Glenda. So this time we're going to put it in the second equation, so this one here. And we know that it's going to be $13 for the call out plus $1.9 for every minute, and it's 10.5 minutes. And if you put that in a calculator, you find that the cost is $32.95. James doesn't know exactly how long it will take him to get to the Blue Pebble to meet Andy, so he decides to work out which is cheaper in the long run. Which company would James conclude is cheaper in the long run? So to work out what taxi service will be cheaper in the long run, we need to look at how much it costs per minute. For Terry's taxi, it's $2.50 per minute, but for Glenda's taxi, it's only $1.9 per minute. Therefore, Glenda has the cheapest service in the long run because the cost per minute is less. For part G, we want to state the length of time in minutes when the cost of travelling with Terry and Glenda is equal. So to do that, because we've both got cost in terms of an expression involving time, we can just equate those two expressions. So what I mean is we can just find out when the equation CT is equal to CG. So that means we're solving 8.5 plus 2.5t is equal to 13 plus 1.9t. And now if you go ahead and solve that, you'll find that t is equal to 7.5 minutes. For part H, we want to state what the amount of time would be that the other company is cheaper. So we know that Glenda is cheaper in the long run, and we want to know for what length of time is Terry cheaper. So Terry will be cheaper for 0 and t being greater than or equal to it, but less than 7.5 minutes. Or if you wanted to use interval notation, that would be the same as t is an element of 0 included up to 7.5 not included with a round bracket. For part I, we want to sketch the cost of a ride with Terry and with Glenda on the same set of axes below, and we want to label all key features with their coordinates. So we'll do Terry's in purple, and Terry has an equation 8.5 plus 2.5t. So the 8.5 is in fact the y-intercept. So we can put a point here that is when t is 0, the cost will be $8.50. And then we know it's a steep gradient, and that will be the cost of riding with Terry. Next, we'll do the cost of Glenda's taxi service in green. So we know that when t is 0, the cost will be $13. So we can put the starting value here. So when t is 0, the cost is 13. And it has a shallow gradient, so it will be something like that. To finish off this graph, we just need to label this point of intersection. And in a previous part, we already found that they were equal at 7.5. And if you plug that into either equation, you find that the cost of a ride that's 7.5 minutes long is $27.25. So that's the point of intersection of the two graphs.